So today we're going to review the substitution method for solving a system of equations. So the steps to use the substitution method, we're going to solve one of the given equations for one of the variables. It doesn't matter which variable you solve for. I always highly recommend that you look for a variable that has a coefficient of 1. Then you won't have to be dealing with fractions. Once you solve for that one variable, you're going to plug that expression into the second equation in place of the variable, then solve for that variable, and then plug it back in to solve for the remaining variable. We have two special cases, just like we did with graphing. This time, instead of graphing it and seeing that they're parallel, what will happen now, or if they end up being the same line when you graphed it, that was our two special cases yesterday. Today, when we solve, if the variable cancels out and what's left is a true statement, then the answer is going to be all real numbers. If the variables cancel out and what's left over is a false statement, like 2 equals 10, you know that that's not a true statement, then the answer is no solution. So let's go ahead and do a few examples. Here we go. So here is the first one. Again, just like yesterday, we have two equations. The instructions are to take one of the equations and solve it for one of the variables. Now, in this particular system, it wouldn't matter if I solved the first one for y or the second one for x. You can choose. I'm going to just go ahead and solve the first one. I'll do this one in red, and I'm going to just put it into y equals mx plus b form. The reason why I'm going to choose to solve for y is the coefficient in front of y is a 1, and then I'm not having anything to divide by and end up with a fraction. So y equals negative 2x plus 9. Now I'm going to take the second equation, and I'm going to replace my variable y with what I just found y equals. So I'm going to take out the y, and I'm going to substitute what y equals, which is negative 2x plus 9. So I'm going to put this in place of the y. You always have to substitute it into the equation that you didn't rearrange to begin with. So the x goes here, the 4. I'm taking out the y and replacing the expression with what y equals. Now I need to solve for x, but first I have to distribute. So I'm going to distribute the 4 to the negative 2, and that gives me negative 8x. Then distribute the 4 to the 9, and I get 36. Now I'm going to go back and combine my like terms. So I have 1x plus negative 8x, and I get negative 7x when I combine these two, and then drop down the rest of the problem. Now it's a nice two-step equation. I'm going to subtract 36 from both sides. Negative 7x equals negative 35. Divide both sides by negative 7. And x equals positive 5. Remember, when we're solving these systems, we're looking for an ordered pair. So far, I found half of that ordered pair. Now I need to go back and find the value of y. Now, I have 3 different places that I can get my value of y from. I can either choose to plug it into my rearranged equation or back into one of the two originals. I'm going to use my rearranged equation. So I'm going to plug it into my rearranged expression. I'm going to plug it into the y equals negative 2x plus 9. So I'm taking out x, and I'm replacing it with a 5. So y equals negative 2 times positive 5 plus 9. And then I get y equals negative 10 plus 9, and y equals negative 1. My solution to this system is the order pair 5, -1. Remember, you write it in alphabetical order. X comes first, then the Y. Now, one way that you can check your solutions is you could plug this order pair back into both of the original equations. If it doesn't work and give you true statements, then you've done something wrong. So this is always a way that you could check to see if an order pair is a solution. Let's try another example. Example 2, still using the same method. So what we're going to do here is, again, I'm looking at my equations and I want to solve one of them for either X or Y. I'm going to choose the first one and I'm going to solve it for X this time because the coefficient in front of X in my first equation is a 1. Then I don't end up with a fraction. So I'm going to take my first equation and I'm going to solve it for X. So I'm going to add 2y. And I get X is equal to 2y plus 4. I now take what I just found X to be equal to, and I'm going to plug it in to my second equation. So I'm taking out X, and I'm replacing it with what X equals, which is 2y plus 4. So I'm going to go ahead and replace 2y plus 4 minus 5y equals 4. I now need to distribute the 2 to the 2y and to the 4. So 2 times 2y gives me 4y. 2 times 4 gives me 8. Drop down the rest of the problem. I now need to combine my like terms. So I can combine 4 minus 5y and get -1y. Drop down the plus 8 and the equals 4. I now need to subtract 8 from both sides. -1y equals -4. Divide both sides by -1 and y equals +4. I now need to find my X value. Now, here's where it's really important that you're writing neatly because remember on the other example, I solved for X first. So make sure that you're labeling what you're solving for so when you go to write your order pair, you're going to write it in the right order. So now I'm going to take what y equals. I can either plug it into my rearranged, which is the easier one, or if you'd rather, you can also plug it in to one of the two at the beginning. Either way, we can solve for X. But I'm going to take my rearranged equation, my X equals 2y plus 4. I am going to replace y with 4. So X equals 2 times 4 plus 4. 2 times 4 is 8, and then 8 plus 4 is 12. So the solution to my system is the order pair 12, 4. So notice on number 3, the first equation is already solved for y for me. So what I'm going to do is I'm going to take what y equals, which is the 4x minus 5, and I'm going to replace my second equation. I'm going to replace y with 4x minus 5. So 8x minus 2, replace y with 4x minus 5, and then equals 20. I have to distribute. I'm going to distribute -2 to the 4. I get -8x. -2 to -5 gives me +10. I now need to combine my like terms. Notice 8x minus 8x is gone. It's 0. And now I'm left with 10 equals 20. This is nonsense. This is a false statement. So when the variables cancel and you're left with something that is not true, then the answer is no solution. So when you're left with a false statement after the variables cancel, the answer is no solution. Yesterday when we did this, we would have found that the lines were parallel. Now, if you use the graphing method like we did yesterday, for example, if I take 8x minus 2y equals 20, and let's say I want to get it into slope-intercept form, because I wanted to see if my slopes were the same. Once I do that, you're going to end up with the equation y equals 4x minus 10. Notice the slopes here are the same. They both have a 4 in front of x. Remember, when you have the same slope, the lines are parallel. Okay, so example 4, it's got some crazy looking fractions here. So again, it still wants me to use the substitution method. So what I'm going to do with this is, so I don't have to work with fractions and substitute them in, I'm going to get rid of the fractions by multiplying the equations by the LCD, or the common denominator. So for my first equation, my common denominator here is going to be between 2 and 3 is going to be a 6. So what I'm going to do to clear the fraction, I'm going to distribute a 6 to this first term. So this gives me 6r over 2, which is going to simplify to 3r. Then I'm going to distribute it to the s over 3. This will give me 6s over 3, which will give me 2s. Then I'm going to distribute it to the 1, and I'm left with equals 6. I'm going to do the same thing on the second fractions. I'm going to multiply by its common denominator, and the LCD between 4 and 3 is going to be 12. So I'm going to distribute 12 to each of the terms. So this will give me 12r over 3, which is also going to give me 3r. Then I'm going to distribute it to the 2s over 3. This is going to give me 24s over 3, which will be 8s. And then distribute it to the 1. And that's going to give me 12. Now, I'm using substitution here though. So what I need to do is I need to solve for one of the variables. Now, I could go ahead and get some fractions, but just to show you something a little bit easier, I could solve the red one and I could get 3r by itself. 3r is equal to negative 2s plus 6. Now what I could do is take what r equals, 3r equals, and I could replace this whole thing in there. Now you could divide it by 3 and get fractions, but it's a lot easier since these are the same. Just replace the whole thing. So I'm going to replace negative 2s plus 6 plus the 8s equals 12. All right, so I'm going to go ahead and add my like terms. Negative 2s plus 8s will give me 6s equals 12. I forgot my 6s, sorry. And then I also have a plus 6. So then I need to move the 6. 6s equals 6. Divide by 6, and s equals 1. Now, let me just show you a variation of this. If you didn't plug in the whole thing for 3r, let's say you took the 3r minus 2s plus 6, divide all of this by 3, and then get r equals negative 2/3 s plus 2. then this is what you would have to plug in to this one. 3r plus 8s equals 12. I'm going to take this and plug it in just for the r. So this is another way you could have done it. But since the whole thing was a 3r, I just left it alone. But this would be the appropriate way to do it by getting r all by itself. And then now distribute, and you get negative 2s plus 6 plus 8s equals 12. Combine these like terms, and this is the same thing I just solved over there. So this is another way to do it. Divide, and s equals 1. Now, we've only found half of our ordered pair. I now need to take what s equals, which is 1, and then plug it back in to one of the originals. I'm going to go ahead and plug it into my rearranged. My r equals negative 2/3 s plus 2. So I'm going to take this s and replace it right here. So I get r equals negative 2/3 times 1 plus 2. R equals negative 2/3 plus 2. I need to find a common denominator. My common denominator is going to be 3. So I'm going to turn the 2 into 6/3. And then now I end up with r equals 4/3. You're going to write it in the order pair alphabetically. So r comma s. So that'll be 4/3 comma 1. The equation that I plugged this into was up here, where I rearranged it and divided by the 3. So this is where I got this from. All right, last example. Again, it says to solve by substitution. Now, notice all of my x's and y's have coefficients. So I'm going to get a fraction no matter what I decide to solve for. So I'm going to go ahead and solve the second one for x because it already has x isolated. So all I'm going to do here on this second equation is divide everything by 10. This will end up leaving me with x equals 4/10 will simplify to 2/5. And then 10 divided by 10 is 1. So then now I have to plug it back into the other equation. So I'm going to take out x and I'm going to replace it with what x equals. So my first equation is the 5x minus 2y equals negative 5. Again, I'm replacing x with what I just found x to equal. So I'm going to go ahead and distribute a 5 to the 2/5 y minus 1 minus 2y equals negative 5. Distribute, and I get 2y minus 5 minus 2y equals negative 5. Notice when I combine 2y minus 2y, these are gone now. It cancels out. So now I'm left with negative 5 equals negative 5. This is a true statement. So when it's a true statement, it's going to be all real numbers or infinitely many solutions.